Good morning, everyone. Good morning and welcome to the tools track of the TestCon conference of 2022. I'm Martin Gijs, I'm your track chair, and I will be introducing right now Mr. Istvan Forgacs. He is presenting today on, do you know how good you are at test design? We don't think so. Why? Istvan claims that many testers do not know how good their test designs are, and he will not only explain why, but also share how a special web application that he made can help you practice your test design and improve it. Please note that Packett and Manning, the publishers, are awarding active participants for their reactions and their votes. And then I now give the stage to Istvan.
Thank you for the introduction and good morning, everybody. So I will speak about test design and especially on how to improve your test design knowledge. Some sentences about me. We introduced testdesign.org with my friend and co-author Attila Kovács, and this is the only site when you can really exercise test design and improve your knowledge. I'm the initiator of a test design automation tool Harmony, and I'm the co-author of these three books. Two of them are about test design. And with Attila, we also introduced three new test design techniques, action state testing, general predicate testing, and combinative testing. But today I will speak only about action state testing. And I also introduced double phase model-based testing. You will see this. So the first question is, what is test design at all? A test design technique is a procedure for determining test conditions, test cases, and test data during software testing. It means that you should plan test cases in a way that the test cases will detect all the bugs or almost all the bugs. And if so, then your test cases are reliable. In most of the test design techniques, there is a test selection criterion, and that is very good because you know when to stop adding new test cases. So there are many test design techniques according to ISO, IEC standard, and most of them are specification-based test design techniques. The next question is, why appropriate test design is necessary? The answer is very simple. Without test design, the defects remain undetected, and in this way, the code quality becomes low. And obviously, users will hate to use the application, and they will looking for a better app, and they will change to another app. So the good news is that most test design techniques can be automated or can be automated in part. And most tools that automate test design are called model-based testing tools, shortly MBT. So, and what is more, the modern test automation tools are MBT tools, and but the problem is that there are many types of MBT tools, but only stateful tools can find the tricky bugs. And most of the tools are stateless tools. Okay. The next question is how to measure test design knowledge. It's easy for the developers. By developers, knowledge can be measured by the bugs found by the testers, the bugs found by the users, or the developers can apply static analyzers, and static analyzers are very good because any problems with the code is reported, and the developers can improve their knowledge knowledge based on the static analyzer reports. However, the tester's knowledge is more difficult to measure. The only thing is to map the bugs found after release with the testers, but it's an extra effort, and quite a few companies made this extra effort, especially if software is tested by several testers. Okay, and in this way, even the testers themselves don't know their level. And I'm not an exception. I also believe that I'm good at test design. There is a single method, mutation testing, which is good to measure the test cases and therefore the testers. So some words about mutation testing. This is the only known method to validate the reliability of the test design and the testers. During mutation, the correct code is modified. If it's modified in one location, then this is the first order mutant. And generally, we use first order mutants. To make the method reliable, there should be lots of realistic mutants. And if the test case kill the mutants, this means that the test case will differentiate the original, the correct code, and the mutant. And we want that the test set will kill all the mutants, but it's not an easy task. And if so, then the test set is called reliable. It's usually it's not the case, and in this case, the percentage of killed mutant divided by all the mutants is the reliability percentage of the test set. There are several commercial tools to generate mutants. However, these are textual methods without knowing the application, the correct application deeply. So these mutants are not quite reliable. And another problem is that the method is quadrative, so it can be used only for small programs, small codes. And there is another problem that is the equivalent mutants, which means that the mutant and the correct code, or not correct, but the original code is equivalent, and there is no method to decide whether the mutant is equivalent or not. So, how to exercise test design? When we started with our website, there was no website where there are test design exercises. And we want to make one. And first, we set up some requirements. So first, the exercises should be application that are easy to understand, but not easy to test. The test sets can be executed, and the test design effectiveness can be measured. And it's not enough because we want that the testers, that we support testers to improve, which means that if somebody don't kill a mutant, then we tell which is the test case which would do this. And finally, the test cases can be easily automated. Okay, the solution is the testdesign.org website. Now it's becomes popular, and we developed a mutation testing framework. We created till now 9 original specification with a few requirements. And for each specification, I do this task. I implemented and tested the code, and I produced some mutants based on the initial real bugs. It was easy for me because I'm not a good developer and I made lots of bugs. And when my code was close to the correct, the last bugs, the last version becomes the mutant. And I add more mutants according to my former bugs. And in this way, I think we have very good mutants. Then I made the test design and automated the test because I'm lazy and it was much easier to execute the tests. And finally, I evaluate the test design and we made some improvements if the specification wasn't good enough. Here is an example. This is one of the simplest exercise in our website. Here the rental company can loan different vehicles and can add any vehicle to the rental or order one by one, and obviously can remove any vehicle one by one from the rental order. And if the customer rents two cars and or one car and I'm sorry. So if the if the customer has selected some bikes previously, then one of them becomes free. On the other hand, if the customer hasn't added any bike, then the bike becomes freely added. Okay, and if the customer deletes the free bike from the order because he or she don't want to rent any bike, then the price will be reduced by 50 euros. And the last requirement is that if the customer deletes some cars so that the threshold doesn't hold, then the offering will be withdrawn. But if we add the cars or motorbikes again, then we give back the same offering as previously. Okay, so we developed the mutation testing framework. It's easy to use. You can see that there are quite a few inputs and outputs. And when we execute the code, we also execute all the mutants, and the killed and unkilled mutants are counted. And if somebody again, and the user can press next test for the second or third test, try again if some failure, and finally, if somebody believes that his or her solution is okay, then press show my result. And in case of any unkilled mutant, then there will be a message saying what is missing testing, as you can see here. Now, here is a video, very short video. I add two cars, and then I delete the free bike, and that was the first test. I press next test, and now I add a bike, then two cars. Okay, and when delete and show my result, and you can see that a third of the bugs have been found. And it's not as surprising because in the first period of testing, considering the first test cases, it's easy to find the bugs, but it's very difficult to find the last, for example, 3 bugs. Okay, so in this example, I made 15 mutants and I asked 10 testers to do exploratory testing and they did it. They had 20, 30 minutes and I also tested the application, but I used use case testing. But nobody found nobody found all the bugs, and the average was 66, which means that 5 of the bugs have been found. But I found only 80% of the bugs, and it's really shocked me because at that time I was the lead author of the practical test design book, and I had several presentations and tutorials about test design. So I analyzed the causes and I realized that I didn't consider the states. Okay, an easy solution would be to use state transition testing, but occurred that it's not applicable. If you are surfing on the net asking when is a system stateful, then the original software engineering answer is that if a system gives a different output for the same input, depending on its earlier state. However, it's not good for state transition testing because, for example, if we add several bikes to the cart, then the output will be different, 1, 2, 3, 4, 5, etc. But the input is the same, add one more bike. So it's not a good solution because it would result in trillions of states. So states should be determined in a new way. But there are some other problems. So the one problem is invisible paths. If there is any test selection criterion, it's all based on the graph and the traversing of the graph. And if you traverse the graph and you have a test case set at a test steps, then there may be invisible step. And to handle this problem, you should have so-called guard conditions, but this is actually code. Other problem is that output cannot be involved directly with the same reason because along different paths, the output will be different. And finally, there are systems where the stateless solution is more appropriate. But this is not for this current system. So there are pain points by applying traditional methods. And we need a test design technique that consists of states only optionally and which really doesn't require any coding and consists of the output in the model. And we had a solution called action state testing. This is a textual model that consists of steps, and each step consists of 3 elements. A user action, this is obligatory. A system response, this is optional because you don't need to validate the result after each action. And finally, a special state that is also optional. Here is an example. The action is add the car to the cart. The response is that one car in the cart, and the state is that there is no offering. Now, I mentioned that the current computation or creation of states is not good enough. And here is a better solution how to handle states. If a system calculates the output differently for the same action, depending on its earlier state, then after the action finished, we arrived at a new state. So the difference is that not if the output is different, we have a new state, but only if the output calculation is different, we have a new state. And this will reduce the number of states largely. For example, adding 4 items to the cart one by one, the computation is the same and we arrived at the same state. However, adding the 5th item and getting a price reduction, which is a different calculation, then we arrived at a different test state. This model is implementation independent, as this is very good because you can use it when the specification, when the requirements are ready, or in the beginning of any sprint. So here the actions and the responses should be as abstract as possible. For example, add items so that the price remains below 10. It's really abstract because the testers can do in many ways. Here is a more concrete but still implementation independent version. First, add an item for €7, then for 2. And this is below 10 because it's 9. And finally, here is an implementation dependent solution. First, click on the plus icon next to Pizza Mexicana, then the plus icon next to Coke. This is implementation dependent, and this is not good for us because abstract actions and responses should be understandable for only the testers and not for any test automation tools. The modeling is really simple. On the left-hand side, there are 2 steps, and you can see that the second step is intended right. And in this case, we have a single test case with these 2 steps. On the other hand, on the right-hand side, we have also 2 steps, but they are in the same position. So in this case, we have 2 test cases with one step. Okay, and finally, we should map the requirements and the model, and finally the test cases. And we have labels you can see here with green, and this label should be a very short version of the requirement and should consist of the identification of the requirement. A very good thing with this model is that the original textual model can be converted to a state chart, as you can see here. And this state chart consists of less information, but it's very good for validation because you can easily find the missing actions. And it's also can be used to choose some appropriate test selection criterion because it's a graph. Now let's go back to our car rental example and let's create the states. The first state is when we start that we have no offering. And if we first add a bike, then 2 car, then this bike will be converted, and this is a new computation, and this is a new state. Or we can start from no offering again, and if we add the first car, then nothing new happens, no new calculation. But if we add the second car, then this will be a different calculation because a bike is added, not converted. So it's a new state. And finally, if we delete the bike, we arrived at another new computation because here the price will be reduced. So we have only 4 states. Here is some part of the model. So we start from an initial state that is no offering, and we add a car, and the state is still no offering. And if we now we can do different things. For example, delete a car, and we go back to the empty cart, and the state remains no offering. And if we add a car, this is a second test case, then we have 2 cars and 1 bike, and we arrived at an offering bike added state. If we delete a car, then we go back to the no offering state, and if we add another car, then we remain in the offering bike added state. But if we delete the bike, then we have only 3 cars. And this is the case when the price is reduced, and we arrived at the offering price reduced state, as you can see here in the state chart. So the whole model is a little bit more difficult. So I show you the state chart, and I realized that I cannot add any missing actions to this state chart. So the first model is ready. So I add all the actions and states, and I also covered all the requirements, and in this case the number of test cases is 13. And I found 87% of the bugs, so only 2 bugs have been escaped. To catch all the bugs, a stronger test selection criterion is needed. So I selected the all transition pairs criterion. In this criterion, you should cover all the adjacent edges. And when I did this, the number of test cases became 26, just the double. But it's not a problem because our tool offered the missing steps. And if the tool offered a wrong step, then I rejected it. If a good step, then I accepted it. So the additional time to double the number of test cases was only some minutes. And because, as I mentioned, I'm a little bit lazy, and for me it's difficult to enter 26 tests without error. So I automated before executing, and we use Cypress Runner, and Cypress Runner execute them. Anyway, I should consider only the inputs correctly, because when you use this framework, you will see only the correct application, and the other will be handled by the mutants. So the whole automation and execution took only a little bit more than 4 minutes. And I executed the test cases. I mean, Cypress executed, and it's really fast. You can see here, and we will see what's the result after executing these 26 test cases. and I press show my result, and wow, all the bugs have been found with this new method. Okay, even we can find the last bug. So originally, nobody, as I mentioned, nobody found the last bug in the code. And this last bug became the last mutant finally. And to detect this bug, you should add two cars, then delete the free bike, then delete a car, add the bike, and finally delete the only car. But this last step was really very unpredictable, so it wasn't a surprise that nobody detected it. But fortunately, this new method found this bug as well. So here is my conclusion. Finding tricky bugs is really difficult. Testers have only assumptions about their test design knowledge. And therefore, we introduced a test design exercise framework and we added 9, I think, interesting exercises. And even the simplest one was too difficult to find all the bugs with existing methods. Therefore, we introduced two test design techniques. Here I mentioned only one. And with this action state method, you can find all the bugs, not only in this car rental app, but in all the other exercises as well. Okay, thank you for the attention. Uh, if you want, use LIA method. LIA means learn, exercise, and apply, and use our testdesign.org web page. Thank you. And I'm waiting for the questions, of course.
Thank you, Istvan. That was a very stimulating talk based on the theory, also the academic view of testing. As at this point, we have received one question, and that is, where could we get the slides? Because people would like to dive into this a bit deeper and take a good look at the slides again.
Okay, I will upload it to testdesign.org soon, okay? Today or tomorrow.
Excellent. And since you also shared your contact details, I suppose they can also contact you directly for them if they should like.
Yeah.
All right, that will be good. I also had a few questions that I thought of, and the first one is, how did you discover that your test design techniques, your expertise was not yet perfect? Because as you are applying your techniques, you think, as you already said also in your talk, that you're doing pretty well. So how did you realize that there was something more to be learned here?
Actually, maybe my presentation wasn't good enough, but when I introduced this currental application, I didn't know this new method. I invented, or we invented after I realized that this currental program bugs cannot be found, but that by traditional methods. So I was thinking and thinking how to could find all the bugs, and that's why we introduced this action state method. And another method, general predicate testing, it's another good method because the original method is not good. But I don't want to speak about this topic because it's not the topic here.
All right, thank you. And um, how have test professionals or academic people that you have shared this with responded to the app that you have shared?
Sorry, I don't
All
catch
right.
it.
Uh, since you have created this application, this web application for exercising the techniques, you've shared them with other people to play with, to use, to learn from. How have the
Yes.
responses from people been to this application and the learning process that it supports?
Yeah, it's a very good question. Actually, I have some collaborators who solved other exercises, not only the currental, and they liked it because they said that it's a fun. It's like a puzzle, and he liked it, but I haven't enough responses yet.
All right. Then no doubt that will come as more people, definitely after TestCon, will be using it to hone their skills. Um, are there next steps planned with this concept, with the application, or in your research in this area?
Yeah, sure. So first of all, we want to share our test design execution tool Harmony. Then we want to add more exercises. And with Attila, we are planning a new book and introduce and improve our methods. Mm, We are very
Excellent.
busy.
Excellent. So there's indeed still a lot of work to be done, and also a lot of value for testers still to be gained from this from your work. That I think that concludes the questions that we have, and therefore also this session. So thank you very much, Istvan, for your for sharing all this with us, and for the slides that people can use to think it over a little bit longer. And we hope to see you again at some other conference.
Thank you.
Thank you. Bye.